Stop everything you're doing right now. Because what I'm about to tell you will genuinely break your brain, and I mean that in the best possible way. The universe you live in, the one with billions of galaxies, trillions of stars, and everything you've ever known or loved, was once smaller than a single proton. Let that sit for a second. Smaller than a proton. And then, in a fraction of a fraction of a fraction of a second, it exploded outward by a factor of at least 10 to the power of 26. That's not a number most people can even write out without losing track of the zeros. That's a 1 followed by 26 zeros. And that expansion didn't take millions of years. It didn't take thousands. It didn't even take 1 full second. The leading scientific models suggest this entire cosmic explosion, called inflation, happened somewhere between 10 to the negative 36 seconds and 10 to the negative 32 seconds after the Big Bang. We're talking about an event so fast, so violent, so incomprehensibly powerful that the human mind has no natural reference point to grasp it. Here's where it gets controversial. Because most people walk around thinking the Big Bang was just a giant explosion, like a bomb going off in empty space. That's wrong. That's completely wrong. The Big Bang wasn't an explosion in space. Space itself was the thing expanding. There was no center. There was no edge. Every single point in the universe was simultaneously rushing away from every other point. And during inflation, that expansion happened faster than the speed of light. Now, before you say, wait, isn't that impossible? Here's the thing science doesn't always advertise loudly enough. Einstein's theory of relativity says nothing with mass can travel through space faster than light. But space itself? Space has no such speed limit. Space can expand at any rate it wants. And during inflation, it absolutely did. Now let's talk about why this matters to you, sitting wherever you are right now. Because if inflation hadn't happened exactly the way it did, you wouldn't exist. Not even close. The universe would have either collapsed back on itself within microseconds, or it would have expanded so rapidly that matter could never clump together to form stars, galaxies, or planets. The fact that our universe is so staggeringly uniform, that the temperature of the cosmic microwave background radiation, the afterglow of the Big Bang, varies by only 1 part in 100,000 across the entire observable sky. That uniformity is the fingerprint of inflation. Without inflation, the universe would be a chaotic, lumpy, unlivable mess. With inflation, you got Earth. You got oceans. You got life. You got this moment. But here's where scientists get uncomfortable and honest at the same time. We don't fully know what caused inflation. The leading theory, proposed by physicist Alan Guth in 1980, suggests that a mysterious energy field called the inflaton field drove this expansion. When the inflaton field decayed, it released its energy as matter and radiation, essentially kick-starting everything that became the physical universe. But the inflaton field has never been directly observed. It's a mathematical solution to a real problem. That's the brutal honesty of frontier science. Sometimes you know the what long before you know the why. And yet the evidence for inflation is extraordinary. The 2014 BICEP-2 collaboration initially claimed detection of gravitational wave signatures from inflation in the cosmic microwave background, a signal so exciting it made physicists cry in real time. That specific claim was later revised after accounting for galactic dust interference, but the search continues. The Planck satellite mission data from the European Space Agency, completed in 2018, confirmed the extraordinary flatness and smoothness of the universe, both strong indicators that inflation occurred. Scientists aren't guessing here. They're reading the universe's birth certificate, and every line of it points toward this catastrophic, beautiful, instantaneous expansion. Here's the part that should absolutely haunt you. If inflation happened the way the math suggests, our entire observable universe, every galaxy the James Webb Space Telescope has ever photographed, every star, every planet, every atom of your body, represents only a tiny, almost laughably small patch of what actually exists. The regions beyond what we can observe, the regions that were also inflated outward in those first incomprehensible fractions of a second, may extend so far beyond our cosmic horizon that the observable universe is to the total universe what a single atom is to the entire Earth. Maybe smaller. Some models suggest inflation could have produced not just one universe, but an endless sea of universes, the multiverse, each one a separate bubble, each with potentially different physical laws. And here's the controversy nobody talks about enough. If the multiverse exists as a product of eternal inflation, it may be fundamentally untestable. A theory that can't be tested isn't science in the traditional sense. It's philosophy dressed in mathematics. This is the tension living inside the greatest minds in physics right now. They built a theory so powerful and so successful that it may have explained itself right out of the reach of experimental verification. You are a creature made of star stuff, living on a pale blue inside a galaxy that is one of an estimated 2 trillion galaxies in the observable universe, all of which burst into existence from something smaller than you could ever see, in less time than you could ever measure, driven by forces we are still only beginning to understand. That's not science fiction. That's your actual address in reality. If this kind of truth makes your brain feel alive, follow this page right now, because we go this deep every single time. So tell me this. If the universe is far larger than we can ever observe, and if other universes may exist beyond our cosmic horizon with completely different physical laws, does that make you feel more significant knowing how precisely our universe was tuned for life, or completely insignificant in the face of scales this enormous?